next question, we have been given an irregular quadrilateral. Yeah, so it's a quadrilateral means the four-sided shape. Is irregular means it's not a square. A regular quadrilateral would be a square. So this is an irregular quadrilateral. So these are the angles that have been marked on here. We need to figure out what the T is. Now, we can assume that even though everybody knows that the quadrilateral adds up to, what do internal angles add up to the quadrilateral?
360.
Okay, so we all know that, but for the sake of argument, we don't know that. So let's look at it if you were to work it out with the formula. So with using the formula would be Halima n. I did ask for a green. It would be n. Okay, that doesn't look too nice now. N minus 2 time by 180. Now the n value is equal to, how many sides we have?
4.
So n is equal to 4 because it's quadrilateral. So 4 minus 2 times by 180, which gives you 2 times by 180, which gives you exactly the number that you told me earlier. But now we're just working out using, how would we work out using the formula? So that's 360. Now let's get back to the question now. So we know that all these four angles must add up to 360. So let's form an equation. So we start over here first, T. So we said T add 4T add 3T add 80 is equal to what?
120. 360.
360. Yeah, 360. Now, because we got here, these are all T terms, and these are called like terms.
Yeah.
When they are like each other. Not like terms as though you like ice cream or something completely different. So T at 4T at 3T, that will give you 5T. 5T at 3T
8T
is 8T. No, Yusuf.
8T cubed.
That'll give us
8T cubed.
No. 8T, not cubed. We're not multiplying them. Just think of T as something tangy. I have 1 tangy sweet, I had 4 tangy sweets, gives you 5 tangy sweets, I had 3 tangy sweets, gives you 8 tangy sweets. The T wouldn't change because you count the in sets of T's, yeah? It only change if you multiply them. So if you did T times by 4T times by 3T, then you would have an answer with T cubed in it. That's right. If you were multiplying. Why you open them down for sorry? Okay, 8T. Oh yeah. Like a turnip. Okay, 8T add the 80 will give us a total of 360. So what we've done here, so if you look at the first line, we have, what's that called? Formed an equation, yeah? And then on the as we go to the second line, we have simplified it. That's what we're doing over here. Now we're going to solve it. So we're using the algebra skills we learned from the previous lesson into a polygon question. So, Mr. Ali, I want to work out the value of T. It's been timed by 8. Whoops, I was trying to put time in there. This is called my first action. And then it's been added by 80. It's called my second action. So, Mr. Ali, which action do we move first?
First action.
You always move the last action first when you're solving equations. We label it first, second, then we can identify it. So opposite of add 80 is? Minus 80. So 8 times by T is equal to 360. Take away 80 is equal to 280. Now we've got to work out the value of the T. So Mr. Ali, T is being currently multiplied by 8. What do we do with the time by 8?
Divided by 8.
Divided by 8. So, Mr. Fahmy, on the calculator, what is 280 divided by 8? Have you done it yet? So, 280 divided by 8 is the same as dividing by 2, dividing by 2, divided by 2. 3 times. The answer is? 35. You sure?
Yeah.
Yes. 35, then 35, 70, 71, 40. Yeah, that looks good.
What is it?
35 degrees. So, now that you know T is 35, you can go back and fill in all the missing angles. So we can go back over here and say, oh yes, this T is equal to 35. This one is 3 lots of T, so that'll be what? 35 times by 3, which will be 35, 70, 70, yes, so that's 105. Oh, no. 105. 100 and? Excuse me about that. Doing a bit of doodling there. And this one's going to be 40. So 40 will be what?
140.
140. Now, can somebody check your mark for me, please? Can you add them all up? Make sure you add up to 3.
Yes.
Just 360, yeah? So this question is again the next level up. So what we're doing here, we're using the same formula. We are forming equations, simplifying equations. So we are revising our algebra knowledge, algebra practice in a polygon environment. Okay, now, if you look at this sheet, can you see some of the questions have got no diagrams, they've got writing?
Yeah.
Should we do one of those now? Yeah?
Yeah.
Should we do one of those next?